1/2 times base times height.
Two formulas today. Right, we're gonna split this into two parts, so to say here. We're gonna focus on triangles first. What's their formula? Do some of them, and then we'll work on the trapezoids after that here. So, same general concept here. Doing one or two things. Either find the area, in this case, triangles, figures, words, trapezoids, figures, words, and then finding missing dimensions of triangles, trapezoids, triangles, or trapezoids here. So, not real concerned with 18 here. You can skip 18. You don't have to do 18 here. I don't do anything with this unit conversion type stuff here. We don't need to focus on that this year. We'll cover that next year in some depth, but either way, skip 18. Don't need to do 18. So, all right. So let's start with triangles here. So I'm just gonna draw out a triangle of my own here. Make it like that. Throw a little right angle on there. And I'll say this is 16 inches here. I'll call this 14 inches over here. And I'll call that 10 inches right there. So similar formula, but with a triangle here, let's see if they have a good picture of how this works here. Not really. But if I draw out this triangle here, and if I draw the exact same triangle more or less right here, right? Would you agree that this is more or less a parallelogram that's been formed? Yeah, and it will be. If I copy any of these triangles here, I'll basically just make parallelograms all over the place. A triangle is half of a parallelogram. It's just half of the parallelogram. That's what it is. And any triangle I could, again, like I showed you, you can draw all these lines here and complete what the other half would look like and just turn it into a parallelogram. So knowing a triangle is essentially just half a parallelogram. For our formula to find the area of a triangle, it's just 1/2 of the base times the height. So very similar to the parallelogram formula, where the base and the height will again form a right angle. So that's what we're going to be looking for here. We're going to be looking for that right angle to be formed here. Just like with the parallelogram, there may be extra information provided to you. So I see in 1 and 2 here, they got 3 numbers, but one of those numbers we don't care about. For number 1, we would be interested in 6 meters. Well, that's the height there, but the base is 12. 7 is just a side length of the triangle. Again, if we were solving for perimeter, we'd want to know that. It'd be very useful, but if we're finding area, this number has no relevance whatsoever to find the area. Just like with the parallelogram, the base and the height form the right angle. So if you're going through, quiz, test, whatever here, you're looking for that right angle here. You should be able to determine on number 2, the base is 18, the height is 4. Again, they show the right angle over here. They could have put it right here too, but technically it's got to get all the way up to there. So they extend it here in a different way. 23 is the long side there. It's just a side measurement there. So going through, plugging in all the information again. If I'm finding area, well, 1/2 times the base, which is 16 inches, times the height, which is 10 inches. Multiply those 3 things together. To do it here, I mean, you can multiply these 2, then divide by 2. You can pick either one of these numbers and just cut them in half. there's quite a few ways you could go about doing it. 1/2 is multiplying by 0.5 on your calculator, or dividing by 2, whatever you want to do here. But if I just go 16 times 10, and then multiply by 1/2, it's the same as dividing by 2, I should get an answer of 80 inches squared. And just like before, the inches times the inches gives us a square inch. 1/2 has no label to it. It's not 1/2 inch. It's just 1/2 because a triangle is literally half of a parallelogram. It's the same formula as the parallelogram, but just half of whatever the parallelogram would be. And again, if this was that, and just say this is 80 inches squared, well, this would also be 80 inches squared, and then the parallelogram itself would have an area of 160 inches squared. So triangles are always just half of parallelograms. If you make a perfect copy of the triangle and just attach it to the one you got, you will have made a perfect parallelogram with 2 sets of parallel sides that are congruent to each other. So there we go, triangles. Sam, you may not have heard, but what's this stuff here, like 3 and 4, when you're going through representing your answers here, if information is provided to you like number 3 in fraction form, your answer should come back to fraction form. If the information is provided to you in decimal form, then your final answer should also come back in decimal form. So if you're like, what do I do? What do I write here? Whatever form the numbers are in the question, this I would look for a decimal answer, this I'd look for a fraction answer. Does that make sense to you? Right, so that way you know like what type of, your final answer should be. So this right here, again, don't really need the formula here, but for all practical purposes, this is what our work would look like here. We're not really undoing anything. We're just multiplying 3 values together. It's a one-step process. Multiply this, that, and that, and you're done with it here. So I'll give you another one here. Or you can try number 3, I suppose. It says the base is 5 3/4 centimeters. The height is 16 centimeters. What is the area of that triangle?
So when you simplify the next number,
Yep.
and then do the equation?
So I know that I'm going to be multiplying by this here. So a good way to go about setting this thing up here is, again, you want to set up your formula. So 1/2 times the base, which is 5 3/4, times the height, which is 16. So to write it all out here, probably the easiest way with everything you're doing here is I'm multiplying 3 values together. I'm multiplying 1/2 times, next numbers should turn into improper fractions, 23/4 times 16 over 1. And you could then approach this a couple different ways. One, I could cross simplify, and everything on the bottom will go away if I cross simplify. Or you can just multiply whatever you got on top. On top, I got 23 times 16, so I get 368 on top. 2 times 4 is 8, and then just divide. Whatever you have on top divides by whatever the product is on the bottom, and that would give me 46. Right. And again, you'll always have 3 if you're working it out this way here, and I would probably utilize this strategy here for something like, again, if I have, fractions involved. That's a trapezoid. We'll cover that in a minute here, but and yeah, I could use cross simplifying too. 16 is 4, 4 is 1, and then I can cross simplify the 4 as well. And then all I'm left with on top is 23 times 2, which is 46 there. So if you go this way here, again, you can cross simplify anything with the top and bottom here. but it'll make it real clear then for what your final answer should be here without having a bunch of odd looking decimals show up in your calculator on you that you're like, I don't know what to do with that, or I don't know what the answer is in fraction form. So, but this is how I would suggest probably setting this up. Always convert your mixed numbers to improper fractions. Whole numbers are just represented by being over 1, and of course 1/2 is just 1/2. All right. I'll give you another one here. I'll say the base is 11.6, 11 6/10 meters. Height is 5 3/10 meters. What is the area of this triangle? So write out the problem that you're solving. What are you solving for? It's your variable, most likely a in this case here. So there's my formula right there. Again, a, that's my variable. That's what I'm solving for. What are you solving for? I'm trying to find the area. So there's my variable there. Multiply the three values together. What's my area?
30 and 7,400 meters square.
30 and 7,400 meters square. Yes?
Yeah.
Sounds about right to me. Okay. Good with that for the moment. Okay. Let's go down to, we'll look at number 13, and then I'll create a couple for you. So we're skipping down. I want to just stick with the triangle for the moment, then we'll come back to the trapezoid. So now we're finding a missing dimension in a triangle where area is provided to you. You're finding either the base or the height. So if you remember how we did this yesterday, you'll plug in the two, you'll know two of the three pieces of information. And you can plug them into the formula. And what are you solving for? So establish your formula first. Again, it's 1/2 base height. And then plug in what you know to be true into the formula. So I know the area, 136 4/10. Since I'm working in decimal form here, I'm just going to call 1/2 0.5 for our purposes here because we're operating with decimals in this situation. So 0.5 times the base, which I know that's 12 4/10, times the height. So I plug in the area where that goes. I plug in the 1/2 where that goes. 1/2 is a constant. It's always going to be a part of the formula here. And then I plugged in the base where that goes. That's that right there. And of course the height, that's what I don't know. That's my variable. That's what I'm solving for. I'm trying to figure out the height. So just plugging in all the information. What would I want to do next here?
Multiply the 0.5.
Right, I can combine these terms together over here, and that's exactly what I want to do next. So just go to your calculator. 5/10 times 12 4/10 equals 6 2/10, still times the height. Now it's just the one-step equation to finish it off here.
Divided.
Right. What am I doing to h? Multiplying by 6 2/10. How do I undo that? Divide both sides by 6 2/10 here.
22.
Yep, and then take that, divide by 6 2/10. Height 22 inches. Measurements are always just normal units, not square units. And that's it right there. So slightly more entailed than yesterday, just because we're just incorporating this guy into the equation this time here. But when you're solving for that inside measurement there, again, you're always going to end up a situation where your first move is going to be to combine your like terms.
I feel like the hardest part of the number here is that only one of the numbers is squared.
Right, we covered that in depth yesterday, and I showed kind of in more detail somewhere. I threw it out. I wrote it all out with all the labels and how the labels cancel each other out. So if you watch the video, I go through that in a lot of depth with the labels, and I wrote things out with all the labels. And well, you guys remember that, right? We covered it. I'm just not doing it today because we did it yesterday. But right, the labels itself, huh?
So far, it's easy enough.
Yeah.
I imagine I know how to do the last one.
I assure you, that question I answered in great depth yesterday in the video here, and I wrote it out with labels a couple times and showed how the labels combine and why they're squares and why the square removes and stuff, so you can find that. Okay, we'll do one more, find a missing measurement here. Let's see, I'll just find one with some numbers here. Let's see, I'll say the area is 187 and 2/10 meters squared. I'll say the base, don't know that. And we'll say the height is 24 meters, not meters squared, just meters. So what is the base of this triangle here? I'll pull a stick here. You don't have to walk me through the whole thing.
Hang on a minute.
I'll write it all. I'll write it all out though, but you can just give me the final answer, and then I'll write it all out real fast for the camera, or if you don't get it. Looks like 2 of you are ready, and 2 of you are pondering it out still.
Okay, I'm ready.
3 of you are ready, 1 pondering. I think you think you're ready.
He thinks he is. He thinks he is. I think I thought you think.
I think that Sam thinks and Eve thinks that you think you're ready.
Yes. I don't know what I think. I think that I don't know what I think about Colin thinking what he thinks he
All
thinks.
right. What do I got here? Sam, what's my base?
15 and 6/10 meters.
Yay! I did. I got it.
I agree with that.
That's if I got it right.
That is
That's if I got
correct.
it wrong and you're just, I got it, yay!
Oh, so plugging it all in, area 1/2 base height, there's the area, equals 1/2. Again, I'm just gonna go with decimals, maybe I'll have to create some fraction ones for you. Base times height, same thing as height times base, so like that right there. And then combine these two terms, half of 24 is 12. Divide by 12. 187 and 2/10 divided by 12. There it is right there. And again, this is good step by step here. Write the equation. Combine your like terms in your equation. Solve the equation. So I guess that would be 1, 2, call that a line if you want, 3, 4 lines to do this type of thing here. And again, that's what I would like to see on the homework too. Okay, good with triangles?
Yeah.
All right, now we're gonna shift gears here and repeat the process with the trapezoid. Find the area of trapezoids, find the missing dimension of a trapezoid. So, I'm looking at number 5 here. I'm just going to sketch it out. And a trapezoid, again, in a sense, is half of a parallelogram. They actually do showcase it here, with this one in my book, right here. You can see that there's my trapezoid right there, and if they make a copy of the trapezoid, once again, I've turned it into a parallelogram, right? There's the trapezoid, there's the same trapezoid, there they are copying it, and it looks like a beautiful parallelogram. So once again, a trapezoid is a variation of half of a parallelogram. But the difference here is the bases are not the same height. Whatever this bottom is going to be whatever it is up here, whatever this is going to be up here. And when I add those together, they'll be the exact same thing. 1 plus 2 is the same thing as 2 plus 1, right? So it is, but with the trapezoid, we got 2 different bases. And trapezoids do have 2 different bases. The height, again, will be defined by forming a right angle with both bases. They don't usually draw 2 right angle symbols, but you should understand here that these lines are parallel in a trapezoid here. That defines the trapezoids having exactly one set of parallel sides. So if a right angle is formed with one of the sides and this other side is parallel, well, then this has to also be a right angle. So in a sense, the height will form 2 right angles with both the bases. Here, there's another right angle up there. So they'll usually show you the right angle symbol in there. It's a little easier. Obviously, this is not a base here. That's just the side length here. The trapezoids will always form a right angle with one of the sides because these sides have to be parallel here. So what does that leave us here? The formula to find it is 1/2, and then you need to add the 2 bases together and multiply it times the height here. Zoom back a little bit here. So what do I got? I got 4 centimeters over here, 8 centimeters over here, and 20 centimeters over here. And again, trapezoids have 2 bases. So they're called B1, B2, but it doesn't really matter which one's B1 and B2. If you want this to be B2 and that to be B1, then cool, but it doesn't matter. Ultimately, what does matter is these 2 numbers need to get added together. So I'll just call this one B1, and I'll call that one B2. But again, it doesn't really matter. So plugging in everything that I know, trying to find the area, 1/2 times the sum of the bases. So I have 8 up here plus 20 over here times the height over here. So I've just plugged in the 3 values, base 1, base 2, height. In this case here, you'll know 3 of the 4 pieces of information because then we're going to find missing side lengths in a minute here. But trapezoids, you need 3 digits to work with here. Base 1, base 2, height. So separate from the parallelogram and the triangle, we only needed 2 things, the base and the height. So always the first step you're going to want to do here, just like PEMDAS rules would apply, is you're always going to want to add these terms together. So area equals 1/2 times 20 plus 8 is 28 times 4. And essentially, once I combine B1 and B2 together, now I'm more or less at the triangle formula because this is the sum of the 2 bases right here. And then you'll solve it the same way we did with the triangle situation there. 1/2 of 28 is 14, and then 14 times 4 is 56 centimeters.
I got a 70 because I accidentally put 5 instead of 4.
Or you can do 1/2 of 4 is 2, 2 times 28. You can take half of either number here, and that gets rid of the half. I'm just doing it in my head. 1/2 of 4 is 2, 2 times 28 is 56. 1/2 of 28 is 14, 14 times 4 is also 56 here. But that's our process there. So when you're finding the area, first thing you're going to want to do is make sure you add your two bases together. Boom. At that point, it's solving identical to how you solve the triangle formula, where base, height, 1/2, bring it on home from that point there. But this has to be your first step here. You have to add up the base heights first to get your base measurement. Make sense? Why don't you guys try number 7 here? Number 7 says base 1, 1 and 7/500 yards. Base 2, 2 and 2/500 yards. Height 3 5/10 yards. But, a moment, one of you can just tell me what the answer is. Colin, what's the area? Still working on it?
No, yeah.
Okay.
I can do it.
And
Well, you'll have your opportunities.
I think I did this really wrong because I just got 6.890625. Kind of close.
What did you get?
That's seven.
7's correct.
Do I have to round it?
Well, let's see what happened here. So, finding the area, first thing you want to do, write your equation here. I see I'm all decimals here, so if I just want to go to decimal form, then so be it. Base 1 plus base 2 times the height. Whoops, I guess I'm on a different sheet of paper here at this point. Didn't even realize that. So, got that there. So there's my 1/2. Base 1 plus base 2. Next thing I'd want to do is add these two values together. Should give me 4 times the height, which is 3 1/2. Half of 4 is 2. And 2 times 3 1/2 is 7.
Okay, so I was close. What happened?
So half of,
What happened? Come look at this weirdness.
not totally sure where it went downhill for you. You might have
I got this. How did
Must
you
have
add
punched
that out
in.
of that? I don't know. You got 3.9375 out of the bases. What?
I don't really know where that came
What?
from either.
I don't know. You
Yeah,
tried to divide them? What happened? No.
that's 15/16.
Yeah.
0.9375.
No.
Did you know that?
You definitely messed up.
I definitely knew that.
But yeah, so I add those together. That's the first thing I'd want to do here. Should get a nice solid 4 here. And then just like the triangle for it, 1/2 times the base times the height. Half of 4 is 2. 2 times 3 1/2 is 7. Or you can punch it into your calculator if you have to, too. Not saying you can't. All right, one more. See what you can do with this one. I'll write it this way this time. Let's see. B1, we'll call it 5 1/4 feet. B2, we'll call it 6 1/2 feet.
Hold on, I'll these again.
And the
No.
height, we'll
No,
say
don't be a fraction.
3 1/8 feet. There you go. Make it a little more exciting for you here.
Okay, here we go. What?
Work it out here myself, since I just made it up.
Mr. Roger, you're gonna make me cry.
I'm almost done.
Dog, how?
Because he's the mathematician.
Yeah.
You're the math magician.
Oh,
Yeah, I do.
boy. Need my calculator for this one here.
Oh.
What? I don't know.
There, I got it. Woo!
I'm almost done. I am not
I
almost.
am.
Do you want us to round?
Round? There's no rounding needed.
I don't know. I don't think I got that right. Okay, I might. Kind of had this one. All right.
Oh my gosh.
It's reached.
I definitely got this wrong. Oh, I know what I got.
Alright, well, what do we all got here? Let's share.
I'm not done yet. 359.
Fraction.
Oh yeah.
I got that too, but
How do you turn that into a fraction? I forgot.
Well, as a decimal, what did you get?
18.35.
This?
Yeah.
Yeah.
That's correct.
Oh,
With the decimal, but you're right. Well, you could call it 359 millionths and start simplifying it that way. Start dividing by 5 and start simplifying the thing, because that's what it is in word form. 359,375 millionths.
Please don't give us one of these on the
There's one.
test.
So you did all the process right, but you converted everything to decimals, which meant left you.
That's multiplied wrong.
So let's set it up in fraction form here. So again, your process is true. Anybody got it with the fraction?
No. I'll divide by 5. Give me 10 minutes.
I've got 5 and 7, 8.
Not quite, no. So plug in everything that I got here. 1/2 times the sum of the bases. 5 1/4 plus 6 1/2 times the height. 3 1/8.
Yeah.
So first thing I'd want to do, add my fractions. This is 2/4 right here, right? Need a common denominator to add fractions. So 5 1/4, 6 2/4 is 11 3/4.
I converted
Times-
both of those to an improper fraction and then added them. There.
Well, you'll want to do that for multiplying. For adding and subtracting, that's not what you need to do. So 11 3/4. 5 1/4 plus 6 2/4, 11 3/4. So now we're going to multiply. So now I'm going to set up the big thing. 1/2, 44, 47/4. 24 times 25 over 8.
That's what I meant.
Converting them all. So now,
I'm right, I'm at that.
I'll probably want to multiply, what I'm going to do is multiply my numerators together. 47 times 25 gives me 1,175 on top.
Yeah.
8 times 4 times 2 is 64. So there's going to be my denominator right there, 64. But to convert this to a mixed number, because you're like, well, I don't know, this is what I do. I take divide them out here, 1,175 divided by 64, and there's my 18. Now, again, there's your decimal here, but what do I do with all this? So to figure out, I know it's going to be over 64, but the question is what goes up here? So all I need to do is multiply these two things together. 64 times 18 is 1,152. And then subtract that from there, whatever is left over, in this case 23, that's my numerator right there. So when I divide here, what I'm trying to figure out is what's my whole number. It's 18. So I got my 18. And then whatever's left, all this decimal stuff, take my whole number and figure out how many 64s I have. 18 times 64. 18 is 1,152 over 64. 18 equals 1,152 over 64. But of course I have 1,175 over 64. So how much more? I didn't have enough to make another 64, so otherwise I'd have 19 for a whole number. So I obviously have something left over between 1 and 63 of them. But 1152 over 64 does equal 18. But I got 1,175 over 64. So what's the difference? Subtract the two, whatever you have left. That's your fraction right there. Does that make sense how I went about doing that? You guys seem to understand the process fine, but doing it with your fraction work there. So common denominator. Again, not too hard there. And then it's much easier to write it out in this form here then. Just multiply your, if you can cross simplify, cool. But in this case, there is nothing at all to cross simplify. There's no cross simplifying available. Nothing simplifies with anything in this situation here. But then just multiply your numerator lines, your denominator lines, divide them, get your whole number, multiply that times that, and then just subtract to find out what your numerator should be. And again, 64 times 18 plus 23, there I am, back at 1,175. Right back to where I started the thing, converting it back into improper fraction. Huh? All right, last part, probably the trickiest part of the lesson coming up here. So, finding a missing side length in a trapezoid. So, let's try, we found the area of a trapezoid. We found the area of a triangle, then we found a missing side length of a triangle. We found the area of a trapezoid. Now we're going to find a missing side length of a trapezoid. So, let's start with this one here. So, same deal, plug in what you got. I'll tell you that when you're finding the height, it's a lot easier than finding one of the bases. And you'll see in a minute why that is. So, you should have a chance to get this one done on your own here. But finding the height is not as tricky as finding one of the bases. Because again, you need to combine your like terms. So there we go. Find the height of that trapezoid. There's its area, base 1, base 2. What's the height of the trapezoid?
The height of the trapezoid. Is it the same formula as all the other ones?
Area equals 1/2 times base 1 plus the sum of the bases times the height. And whenever you're dealing with trapezoids, you'll know 3 of the 4 numbers.
Fine pop.
Yesterday I was putting a shirt on and both of my shoulders popped. Actually,
Oh, my neck is popped.
All right. Faith, what's my height? She's pondering it out still.
Me too. Me too. Me three.
None of you have it?
What?
None of you know the
No.
No, I have it.
I have it.
Okay.
Oh. I think I have it. I think so, Dad. It's
Still one stick left in here.
it would be
Eve stick.
I was first.
I was second.
I was last. The last blackbird.
Yeah.
I can't do it.
See, the pencil's still moving there.
I didn't know there was that much to write.
All right. What do we got, Faith?
6.3.
6 3/10?
Yeah.
I agree.
I got 10.
Oh.
Eve.
Good job, Faith. Okay, plug in everything again. I'll work through it here. I'll work through it. We'll see what we got. If you got something else, let's see what happens. So plug in all the values that I know to be true. So area, I know that. 1/2 is a constant. Base 1 is 12.
Oh, I
Plus
didn't
base
put the
2 is
63.
8. And then the height.
What do you mean you did?
I didn't put I only put the.
Oh, you didn't divide it.
No,
Okay.
I just did the first part. I didn't divide it by 63.
Dog.
So, yep, plugging in everything I know. There goes there. That one goes there. And of course, that one goes there. And that's the one I don't know here. So same thing you'd want to do first. You want to combine your like terms here. So 1/2, 12 plus 8 is 20 times the height. And then again, you'll want to continue to combine like terms. These two now should be combined. 1/2 of 20 is 10. And then finish it off here. Divide both sides by 10 or just slide the decimal one spot to the left. And there it is, right there. So with these here, set up your equation. Plug in whatever you know to be true. I know the area, I know base 1, I know base 2. Begin the simplifying process. Get in the brackets first. Clear out those brackets, PEMDAS rules. Then combine your like terms, right there, 1/2 of 20, and then solve the one-step equation that you're left with in the end here. Okay? All right. Okay, now we're going to find a missing base here. You ready for it? Okay. This gets a little more intense. So I'll work through this one here with you.
Is there a problem in the homework where we have to find the base?
Uh-huh.
Oh, there is.
Yep. Yep. Let's see. Base 1, we'll say that's the one I don't know. Base 2 is 13 6/10, and the height is 7. Okay. So I'll walk through this here and pay attention because this is a little tricky. So same formula. And again, I'm going to plug in everything that I know to be true. I know the area. There's that. Equals 1/2. B1, I don't know. I'm just going to call it B for our purposes here. That's what I'm solving for. Plus 13 6/10 times the height, which is 7. So at this point here, our variable is in a spot that we can't really access it at this point here. It's pretty much locked out at the moment here, so we have to start clearing stuff out to even get to the variable here. And the first thing you're going to want to do is, again, essentially I'm multiplying 3 things together. I'm multiplying 1/2 times the sum of the bases times 7. I kind of illustrated that a few times. You're multiplying 3 different things together here. But I would want to combine these like terms first. I can multiply these two things together right now. So what's half of 7? Right, so I'm going to rewrite here. I'll leave it in decimal form, 3.5, and then it's still times the sum of the bases here. Pencil's getting a little dull. Switch to my backup pencil. Ready to go here. Okay. And this is you can go about this a couple ways here with distributing, but we're going to have to distribute here at this point, but it's much more efficient and you'll save yourself 2 steps of work by just combining these terms right now. I can't really multiply this right now. I don't know what the sum of this is because one of it's a variable. I can't combine those terms together. There's nothing I can really do here. But on the outside, these two terms, in a sense, I could write it this way. 1/2 times 7 times b plus 13 6/10. That's the same thing. I just changed the order. It's 3 times 2 times 1 is the same thing as 1 times 2 times 3. So the order I multiply stuff doesn't change the outcome at all here. But multiplying those first and third terms together is what I want to do. So now I need to clear the brackets out. You can't do any solving until the brackets are gone. And a lot of this algebra stuff here, again, you've started to see it. We've worked up through 2-step equations so far. Next year, we'll go quite a bit farther than that. We'll have multi-step, grouping symbols, variables on both sides, and those will turn into like 4, 5, or 6-step type of equations here to solve here. But a lot of this stuff, math is kind of divided when you get into the higher levels. You can't just go to the solving and call it a day here. Like in lower levels, I give you a problem, you solve the problem, and you're done with it. Maybe you have to simplify sometimes. But as you move higher along here, you'll realize math is kind of divided into 3 parts here. A lot of problems. Think like first, the pregame work. Preparing the problem just to solve it. And that's what we're doing right here. We're not trying to solve for B yet because I can't even get to B at this point here. So I'm doing pregame work. I'm preparing the problem to solve. Then you'll solve the problem and then you'll have your step 3 is your simplifying stuff, whatever you got to do to represent your answer in the right form, convert, so on and so forth here. But whenever you have brackets and we have to use our distributing, which means I need to multiply both of these terms by 3.5. What's 3.5 times b?
B times 3.5.
It's 3.5b. And then on the other side, what's 3.5 times 13 6/10? You probably want your calculator for that. And 13 6/10 gives you
47.6.
right. Right. So now I have an equation to solve here. This is now a 2-step equation at this point here, where what am I doing to b? 2 things. I'm multiplying it by 3.5, and I'm also adding 47 6/10 to it. So any 2-step equation, what do you want to do first?
Subtract
The adding or subtracting element. So at this point here, solve your 2-step equation, undo the adding, subtract the 47 6/10 from both sides. 73.5 minus 47 6/10 leaves me 25 9/10 equals 3.5b. And then bring it on home, divide both sides by 3.5.
E.
And that's what b is right there, 7 4/10
I know, like.
millimeters. There's our missing dimension right there.
Are we done?
Well, no, you're going to practice 1 now, and then we're done. So, again, one more time. Well, I'll walk through the process again, but just plug in all the information that you know, the area, base, that's what I don't know, base 2, height, combine your like terms here, 1.5 or a half of 7 is 3.5. Then you need to distribute. You got to clear the brackets out before you can solve the equation here. So essentially I'm multiplying each term by 3.5. 3.5 times b, 3.5 b. 3.5 times 13 and 6/10, 47 and 6/10. That point, it's a two-step equation. Undo your adding or subtracting element, undo your multiplying or dividing element, bring it on home there. Okay. Last one here for you. I have to use a new piece of paper, don't I? Ugh. Terrible. I'll say I'll spare you from crazy fractions. How's that?
Yay, thank you.
Labor of
No,
love.
just fractions in general.
So I'll say the area is 575 miles squared. I'll tell you, base 1 is 52. Base 2, I don't know. And the height is 10. Should get a whole number answer here. So maybe that'll make it a little easier. So you're only going to have whole numbers. If you get some fractional type answer in the end, you did something wrong. And when you're finished, I'll let you venture a guess if you wish. If you don't, that's fine, but I'll work through it here. Unless, Eve, you want to do it all. Because you're up, Eve. I can just let you sit here at the big chair and just teach it. You can just work through it.
Can I?
Right. Eve can teach us there.
Well, I think she should actually get to.
Well, we'll see what you guys get for an answer first. So. Monday's lesson's not quite as involved. But Tuesday's lesson's pretty intense.
Worse than this?
Uh-huh.
Oh.
Yeah.
This isn't that bad, though.
Yeah, it takes some getting used to be honest with you. We covered this stuff last year. We didn't do this, though, but we did find area trapezoids and stuff. So. One of you thinks you got an answer?
I'm ready.
All right, two of you? I'll give everybody give you 30 seconds here, and then I'll solicit your opinions.
Stop.
Not required. But. Did you get a whole answer? Oh, well, that's good. You gotta be feeling good about that. You could plug it all back in and just run it, add your answer plus 52 times the height times 1/2 and see if you get this on the other side.
8, 7, 6, 5, 4, 3, 2, 1.
Alright. So Eve, what do you think?
You just want the answer?
Sure.
I don't think it's good, but 62?
62?
Yeah.
Sam?
I got 65.
65? Colin?
I don't know how I ended up.
Wait, no, never mind. Never mind.
Faith?
Cut me out.
Oh, 100.
Oh, I got 63. Never mind. I said it wrong. I got 63. Cut me out.
Okay.
I got 63. I wrote it wrong.
So, let's see what happens here. So, plug in my area, 575, 1/2 times the base, 52 plus b. I could write b plus 52 if you want. It really doesn't matter, these order of these two things here, times 10. So there I go. Got everything plugged in. First thing I want to do is, before I start distributing, is I want to just consolidate this right here. I can combine these two terms together right now. 1/2 of 10 is 5. And then that's where I'm at now. So now distribute, gotta clear out the brackets, which means multiply both terms by 5. 5 times 52 is 260. And then 5 times b is 5b. Now a two-step equation, subtract the 260 from both sides. That gives me 315 equals 5b. Divide both sides by 5. 315 divided by 5 is b equals 63 miles.
like that. Yup.
There's our step by.
I got it right all the way up to when I was.
Yeah, it is 63. I didn't do the divide by 5 part.
I
just
got it
kept it
right
at
all the way up
350.
to,
I was gonna say that was my
5 times
answer, but
52.
yeah, then I realized it was too big.
Right. So
Alright.
it, again, as you can see, there's a number of steps involved in this process here, but you know, it's just trying to kind of work through it piece by piece. You're just trying to get b by itself, but it's just so blocked off initially in the equation here. It takes quite a bit of work just to get to b. You got to get rid of all these things here and the pieces that you go about doing it and all that. There's other ways to solve it that require more steps. So I'm just kind of leaving it at this right now here. Again, the whole key, and this is the only one of these types of equations that really has this level of detail. The circles aren't anywhere near as deep as this. In fact, the circles are probably more closer to the parallelogram than the triangle. They're just pi r squared. You only have literally one number. You square it and then multiply it times 3.14 and you're done. So, but the key is the radius, not the diameter. So you'll have to turn radiuses and make sure you get diameters or in radiuses, but that's not hard to do either. So circles are, again, more on par with the parallelograms than the triangles and trapezoids and their complexity. So Monday shouldn't be, no, triangles aren't too bad. But again, I mean, if you can go through and if you're getting 63, I mean, that is impressive. It's, you know, you're because again, we're going to really start diving into this type of work next year here. Much more detailed algebra work is coming next year. Or if we do chapter 14 or 13, whatever
No. I
that's.
like this kind of geometry stuff. I don't like the other. I don't like the
No,
shape.
I'm with you. That other stuff, the terms and the vertical
I
angle
hate that
this
stuff.
and
I like this
corresponding
one.
angle
This stuff
that.
easy. I
And,
like this.
yeah,
So,
vocab is.
So do you want to do chapter
So-
11 or chapter 14? You said it might give us.
Thanks, Faith.